in this video, we are going to be discussing differentiation by chain rule. Now, what is the chain rule? If I have y to be a function of u and u to be a function of x, in that case, I'm simply going to be employing the chain rule. Now, what is the chain rule? If y is a function of u, this only means I can only differentiate y with respect to u. And if u is a function of x, it means that I can only differentiate u with respect to x. And then that the variable dy all over the x lies when I multiply these two terms together, which is dy over du multiplied by du all over the x. If this happens, observe that du cancels du. I am simply left with what? Dy all over the x. So this simply means that we can only employ the chain rule of differentiation when we have function of a function. So as can be seen in the grand equation, y is a function of u, meanwhile u is a function of x. So which means y is a function of another function. When we have function of another function in an equation, then the only method of differentiation is simply called the chain rule. Now let's pick an example. Let's say we are given y to be equal to cos 2x and we are asked to find dy all over the x. Now what you do in this case is simply, first you say let u be equal to what? 2x. This simply now implies that y itself is now going to be what? Cos. In place of 2x, it becomes what? Cos u. So you observe that when we said u is equal to 2x, this simply means that u is now what? A function of x, because u now depends on x to be defined. So that means if I say let x be equal to 1, then u has a value of 2. If I say let x be equal to 2, then u has a value of 4, which means u depends on the value of x to be defined. In the same way, over here, y is now what? A function of u. So which means if I say u is 30 degrees, then it means I have a value for y, simply cos 30. If I say u is 60 degrees, it means I have a value for y. So which means y now depends on u. So if y depends on u to be defined, that means I can only find what? Dy all over du. I can only differentiate y with respect to u. Similarly, if u depends on x, it simply means that I can only what? Differentiate u with respect to x. And if I carry out these two derivatives, all I need to do is to what? Multiply them together. I will simply have my derivative. It's as simple as that. So let's do this and see. Now I have that u is equal to 2x and I need to find du all over the x. So from u equals 2x, therefore we simply differentiate u with respect to x. If I differentiate u with respect to x, what will I have? Remember, I'm simply going to have 2, right? If I differentiate u with respect to x, I'll simply have 2. Similarly, from y equals cos u, therefore if I differentiate y with respect to u, I'm simply going to have what? If I differentiate cos, I will simply have minus sine. So this will give me simply minus sine u. But not forgetting that u has a value. We said let u be equal to what? Let u be equal to 2x, as can be seen here. So this simply means that dy du, this simply implies that dy all over du, which we just obtain now as sine u, becomes what? Which we obtain as minus sine u becomes minus sine. In place of u is simply what? 2x. Now let's couple together. We have du dx, we have dy du, and we said from our law, if we multiply these two terms together, we have dy all over the x. So this simply implies, remember, dy all over the x will simply give us what? Dy all over du times du all over the x. So this is going to be equal to dy du, remember, gave us minus sine 2x times du dx, that simply gave us what? 2. So this means that dy dx becomes what? Minus 2 sine 2x. Now I will show you a very short approach, or a shortcut approach, in solving questions like this. Okay, so let's do this and see once again. We are given y to be equal to cos 2x, and we need to find dy all over the x. So dy all over the x is going to be equal to, so when differentiating functions like this, if you don't want to go through the long approach of using chain rule, you can simply employ the shortcut approach. Now, what is the shortcut approach? To differentiate a trig function, the first thing you do is differentiate the angle, use the result to multiply the derivative of the trig function itself. It's as simple as that. In this case now, the angle is what? 2x. What is standing in front of the trig function is the angle. So my angle is simply what? 2x. Okay, that is the angle. Now you differentiate the angle. If I differentiate 2x, what will I have? 2. Use that derivative to multiply the derivative of the trig function. Trig function here is what? Cosine. If I differentiate cosine, I will simply have what? Minus sine, not forgetting. So minus sine, then you put back the angle 2x. So this simply implies that dy all over the x is going to be equal to minus 2 sine 2x, which is the same result we obtained earlier. So this is like a shortcut approach to differentiating trigonometric functions when it has to do with chain rule. Now let's solve one more example on chain rule. Now let's say we are given y to be equal to exponential 3x squared, and we're asked to find the y all over the x. First thing to do is simply let u be equal to what? The power of the exponential function, which is 3x squared. If this is the case, this simply now implies that y is equal to exponential u, because we said let u be what? 3x squared. So from here, you see now that y is a function of u, which means I can only differentiate y with respect to u. Again, u is a function of x, which means I can only differentiate u with respect to x. So if I differentiate u, du all over the x, we simply employ the power rule, use the power of the variable to multiply the variable, then subtract 1 from the power of the variable, right? So 3 is a constant, keep it out. Now differentiate x squared, I have 2 times x to the power of 2 minus 1, which is still 1, so that remains x. So this simply implies that du all over the x is actually what? 6x. Now from y is equal to exponential u, I can simply differentiate y with respect to u. And if I do that, derivative of an exponential function still remains the function. So I still have exponential u as the answer. But you know what u stands for? U is simply what? 3x squared. So that means exponential u still remains exponential 3x squared. So having found this, you recall now that, okay, recall that dy all over the x from chain rule is simply what? Multiplying the two derivatives together. So I have dy all over the x, that should be dy all over du times du all over the x, and this is equal to dy over du give us exponential 3x squared multiplied by du over the x simply gives us what? 6x. So this simply implies that dy all over the x remains what? 6x exponential 3x squared. Now, just like we did previously, I'm going to be showing you a shortcut. So the beautiful thing about chain rule is that you can always adopt a shortcut approach to solving these problems without having to go through the whole rule itself. So when we were given y to be equal to exponential 3x squared, we needed to find dy all over the x. Now, just like we did in the trig function, for the exponential function, to differentiate an exponential function, the first thing you do is differentiate the power of the exponential function. Use that derivative to multiply the exponential function itself. In this case now, the power of this exponential function is what? 3x squared. If I differentiate this power, I will simply have what? 6x. So you use this 6x to multiply what? The exponential function itself. So exponential 3x squared. So the result is simply what? 6x exponential 3x squared, which is the same thing as what we obtained when we use the chain rule. Alright, so I will end the video here to avoid too much lengthiness of the video. In the next video, we are going to be looking into random questions involving both chain rule and product rule of normal variables, trigonometric functions, and exponential functions all together. I hope to see you in that video. In the meantime, do well to like this video, share to your friends, comment nicely, and of course, if you're new to the channel, do well to hit the subscribe button and turn on your notification bell so you don't miss out on our subsequent videos when it drops. I will see you in the next video. Thanks.